Hi everyone, welcome to this session. The freedom of Kubernetes requires chaos engineering to shine in production. So welcome to this session, and let's spend 20 minutes and more together and have fun and learn a lot of things, I hope so. So who I am, my name is Henrik Rexed. I am a cloud native advocate at Dynatrace. Prior to Dynatrace, I've been working in the performance engineering landscape. And I've been doing consultings and many type of work. And performance engineer is still in my heart. So that's why I am also one of the producer of a YouTube channel producing content for performance engineers called PerfByte. So check it out. And 1 year ago, I started a fresh new YouTube channel related to observability. So if you're looking for tutorials, anything related to observability in general, check it out on Is It Observable? All right, enough of talking myself. Let's jump to the content. So what are you going to learn with me if you stay with me on the next 20 minutes? Well, a couple of things. So first, we're going to remind a few concepts related to Kubernetes, because obviously we are going to talk about Kubernetes. And we're going to see that Kubernetes can bring a couple of challenges. So we need to test those. And this is why we're going to use chaos engineering. So I'm going to remind what is chaos engineering. And we are going to then jump into the problem on how to validate our Kubernetes settings. And this, of course, with the help of chaos engineering. We will look at various type of metrics and events that we need to collect to validate our experience. So without any waiting anymore, let's start. So let's see the Kubernetes side. And in fact, not the traditional Kubernetes side, the dark side of Kubernetes. Why I'm saying that? Because you will see Kubernetes can could bring you a mess. So just to remind, Kubernetes is an orchestration framework based, of course, on containers. And Kubernetes rely on nodes. So you have two types of nodes, the master node on the top with the different icons you can see here. And on the bottom, you have the worker nodes where our workload will be deployed. So when we deploy, our deployment will go through various states, and Kubernetes will throw different events based on various problems. So when I deploy, the first state of my workload will be pending. Pending means Kubernetes is trying to identify the node where it could host our workload. So based on resources, of course, and probably on taints and tolerance and different policies that you may have applied. Then what would happen is we move to the next state, which is creating. So here, because we rely on containers, Kubernetes will reach out to your Docker registry, pull out the image. If there is an issue, you will have an event. And also you will check that all the requirements related to your workload is there. So if you have secrets, volumes, config map, if they are not present, you will have an error. Once you have the move, we move to the next state, which is running. Running means the pod is starting, but your application has not started yet. So this is the various states, and those states are very important. And on every state, you will have events based on Kubernetes, and we'll see that in details. So once upon a time, Kubernetes killed my workload. Well, let me explain what happened. So here I have a master node, and I have one node where I have two apps. So I have in the slide, you see two pods. In fact, it's going to be two namespaces with two different apps. And in my story, one of the app, less critical, in fact, was eating more resources to the other one. And as a consequence, my second app were killed by Kubernetes. But how did it happen? So first, because the first app was eating too much resources, the Kubernetes were having an event on the node called node pressure. And that means that there's an infrastructure issue. So to avoid that infrastructure issue, Kubernetes will start an eviction process. And eviction means it will select any part of the node available, and it will kill it. So eviction means it kills the pod and it reschedules it elsewhere. So here, okay, maybe in a few minutes, the problem was resolved. We didn't have so much user connected, so no major impact. But it could be worse. It could be worse because imagine where all your nodes are fully saturated. So we kill the pod and we try to reschedule it, but there is no place to put our new pod. So instead of having maybe a few seconds of downtime, now we are fully dark, and our user are basically experience a very, very bad experience. So for this, how can we avoid that situation? A couple of things. First, the Kubernetes a way of resolving the problems. So first, as a requirement, we need to define request and limits. And by defining the request and limits in the definition of our deployments, naturally, Kubernetes will attach a quantity of services, a QoS. And if the there is nothing defined, the QoS will be best effort. If the request is under limit, we will be burstable. And if the request equal limits, we are guaranteed. So why I'm saying this? Because when we have an eviction, it happens on that order. So first, Kubernetes try to identify pods, which are in best effort. If there is no best effort to kill, it will move to the next one, which is burstable. And if there is no burstable pods, it will move to the guaranteed. So that's, first of all, with QoS, at least if you define the right QoS, you will at least make a difference between your pods. The second thing is, on my story, I was two apps, so two namespaces. If I want to avoid having an app eating the resource of another application, I need to put resource quota. So resource quota on my namespace, and for that, I will at least avoid that situation. So let's jump into details on the notion of request and limits, and you'll see why, and we need to go on the details. So request and limits is very crucial. So let's have a look at the request. Request is you define how much resources your workload requires. And in fact, it's very important because Kubernetes, when it schedules the workload, it's playing like a Tetris game. So it sees the shapes coming down, and based on the size of the shape, it moves it and places it on an available spot to make some points. If you don't precise the request and limits, Kubernetes sees a small shape, it tries to put it on an available spot, but suddenly that shape starts to grow. So impossible to win points, impossible to play our favorite game, which is Tetris. So how do you express the request? Well, easy. In CPU, it's going to be in millicore. In memory, in bytes. So if we do the right tests before that, we know how much resources we need to at least start properly our workload. If we define value too high, which you can do that if you want, it's great, but keep in mind that Kubernetes will allocate those resources on the nodes, and those resources will never be used. So if you use cloud vendors, then those workload will cost you more because your node won't be utilized efficiently. The second aspect is the limit. So now we have defined to Kubernetes, I need a 2-bed apartment. And then Kubernetes says, okay, so I'm going to put a contract. You will be able to consume that amount of water per month and that amount of power per month and so on. So that's basically the contract that we have Kubernetes. So limits is a bit different. It's expressed differently. In memory, it's in bytes, so nothing different for us. So if we do the right load test, we need how many maximum memory do I need to run properly my pod. The second one is CPU is different. It's based on CPU function timing. Why is it in function timing? Because it's an heritage of containers. Containers, to be able to allocate resources on a node or on a server, it uses CFS. So it's a C groups and CFS. It's a Linux concepts. And in fact, function timing means I have a CPU cycle, which is 100 milliseconds, and I will define how much time I can consume during that cycle. So if I define, let's say, CPU functions of 20 milliseconds, I mean, I can start working during the period, and suddenly I have passed my time. So Kubernetes, or in fact, Docker, will basically pause my work, and then for the next 80 milliseconds, I'm waiting, and then the next CPU cycle will restart, and I can resume my work. And this behavior of being paused is called CPU throttling. And CPU throttling is basically impacting heavily our applications. So if you define too low, you will get CPU throttling. And if you define too low in the memory, you will have events where Kubernetes will definitely kill our workload. So it will throw an OM kill event. So what I did some tests. So I did a test where I had an application where I removed all the request and limits, and then I reapplied them. So in the left side, you see all the without the request and limits. On the right side, you see with the request and limits. On the top, you see the CPU utilization. Of course, without, we were able to consume more. I mean, no surprise. We put a limit, so of course, we cannot consume as much CPU as we want. But now let's have a look at these response times. When I had no limits applied, I had response time around few milliseconds. And when I reapplied the limits, where I had in fact CPU throttling, you can see that response times increased to 3.8 seconds. Wow. So why do I need to put those request limits? Because it's a requirement, it's a standard, it's a recommendation by the industry. And why I'm telling you this? Because there's plenty of horror stories related to the topic. Lots of different companies went to KubeCon, share their experience related to CPU throttling problems, or even OM kill events problems. And so here there's a QR code, scan, you will go to websites where you have all those stories listed, and it's really interesting to hear about those stories, in fact. So how can we resolve it? Well, we know we're going to have an issue if we define our settings in the wrong way. So for this, no surprise, we're going to do some chaos engineering. We're going to do some tests. So let's remind what is chaos engineering. Chaos engineering is a process to discover vulnerabilities by injecting failures and errors. In fact, it's even said in Wikipedia in production. So don't do it in production, don't improvise in production, do first in another environment, and then you can move off to production. So let's remind the chaos workflow. So the first step is defining hypotheses. So we need to figure out, okay, what could go wrong in our environment? So I have an app, I have a database. Okay, so what happens if I disconnect the link between my app and my database? Of course, I won't be able to write in the database, no surprise. So here, basically, I'm predicting what will happen if I do so. Then I need to define what are the KPI that will help me to validate that everything goes well, or in the other opposites, everything goes wrong. Once we have defined the hypothesis, we can go to the next step, which is defining the experiments. And experiments, in fact, it's always a workflow of tasks. I need to delete this, I need to inject some latency in that line, and so on. Once we have the workflow, we imagine that in the future, when you're mature enough, you're going to do it in production. So you need to also define how you're going to to come back to a normal situation. And then we have KPI to collect. So we have to figure out how we're going to collect those KPI in our environment. And last, of course, once everything is ready, we can run our experiments. So what hypothesis do we need to do for Kubernetes? So for me, there is 3 scenarios. The first one is maintenance. So why maintenance? Because remember, we rely on nodes. When we do an upgrade on Kubernetes, we need to remove a node, do the maintenance on this one, and then we reattach that node. So potentially in production, we will have less nodes during certain period of the year because we do maintenance tasks. So what I expect is I have to size my cluster properly, no issue, everything is stable, no user impact. Then we have the Kubernetes settings, requests and limits, the scenario I explained. My expectation is that my team is awesome, so no error rates, stable performance and everything. And the last is the eviction. So for this, what I need is for my critical app, the most important one, what I expect is no downtime and everything is smooth and performant for my users. So let's have a look at the observability pillars, because we're going to do some tests. We need some metrics, some stuff. So in observability, we need to understand a given situation. And for this, there is various signals that are required. So in observability, you have logs, events, metrics, traces, continuous profiling, and way more. In our case, we are fishing for an infrastructure issue. So we're going to mainly focus on metrics, events, and maybe logs, but we don't need traces in continuous profiling because this is more on the app side. So let's have a look at the metrics and events that make sense for us. So Kubernetes is like an onion. So we have the user sitting outside, so that's the first layer. Then we enter in the cluster, and then we have a node. So the first layer in the cluster will be the node, and within the node we'll have pods, and in the pod you will have containers. So there are different KPI that we can collect. So first, on the out of the cluster, we need to measure the response times, the failure rates from the user perspective. Then on the node side, I need to look at how healthy is my node in terms of CPU, the memory, the number of sockets open, the network, the number of pods running on that given nodes, for example. And then we jump to the pod. We want to see what I've requested, what is the limit, and how we are using it to see if we are efficient or not in those settings. And then in every KPI that I mentioned about CPU throttling and the others, this happens on the container level. So we need to collect at the container level CPU throttling and CPU usage and memory usage. On the event side, there is less layers here, but we're going to fish on the node, all the infrastructure pressure events related to the node. So disk pressure, node pressure, anything, those pressure events will have the consequence and eviction. So it's very important for us to check those events. We can also check a network like node port conflict, anything like this. On the pod level, fail scheduling is a great event, because if we are not able to schedule, then there's a problem on a node. Eviction, of course, we mentioned about it. OM kill event. We can also have unhealthy. That could also be a sign of something going wrong. So now let's have a look at the experiments that we should run in our cluster. So first, what I would do is I will combine the eviction and the maintenance scenario in the same experiments. Why? Because to be able to come to the situation where my node are in pressure, I will probably remove nodes because my cluster has a lot of nodes. So by doing this, I will node drain, so remove nodes. So to be able to do to test both situations, I will first start with some stable load. I will start removing some nodes and see if my user are not impacted. Then once we have finished that part, I will go to the next step where I simulate the eviction. So here I'm injecting some CPU stress on the node. I'm injecting some memory stress on the node. And here again, I will use a load testing solution to measure response time, the error rate. And here, the load testing part, we're not doing limits or a stress. We just do stable load just to figure out that everything is smooth. On the other one scenarios is about our Kubernetes settings. So we deploy pods with has requests and limits. We don't necessarily need to inject any CPU stress or memory stress. It's not required. We need to run a constant load, and we're going to measure the response time, the error rate, and then we're going to compare it with the same workload without any requests and limits, and then we're going to fine-tune those numbers to have the most efficient settings that will match our requirements, good response times, and low error rates. So what do we need to make this happening? So several things. So if you have one cluster, you're going to do where you have your app, you have your tools. I will definitely put some label selectors on the node to have dedicated nodes for our applications and dedicated nodes for the observability solutions and our testing solutions. Because at the end, I don't want to have my experiments impacting my observability solutions or even my load test. I would just want to impact the application. Second thing, once we have done this, we deploy a K8s engineering platform. And for this, I'm using Litmus Chaos, which is a CNCF project. Litmus Chaos has a UI called the K8s Center. You can either use Litmus Chaos on the same cluster, or you have a cluster and then you will basically inject experiments on a remote cluster. So if you do that in the remote cluster, we'll have to install an agent that will help us to inject the experiments, and also a couple of other components. But one of them, which is interesting, is the K8s exporter, because at the end, Litmus exposes metrics in a Prometheus format. What is great with Litmus, it comes with a couple of experiments available in the Chaos Hub, and there's plenty of them for Kubernetes. So node drain, CPU hog, all the experiments I described, they are already there, so I don't have to recreate them. I will just use the default one. For the load test, I will use K6 because K6 has a Prometheus integration, and all my data will come to Prometheus, so it will be easier to analyze everything. But in my case, I use Prometheus, but also use Dynatrace. All the metrics related, when I deploy Prometheus in a cluster, I get some predefined exporters, so metrics to measure the health of the nodes, the containers, the pods. And also I have Litmus, like mentioned, that expose metrics, and K6. So what I would do is all the metrics related to the node and the containers, I have it with Dynatrace, but I will put annotations on the workload related to Litmus and K6 to be able to collect those metrics. And so Dynatrace will also have all the metrics, and I will be able to diagnose in Dynatrace. So a key takeaway for this presentation, two things. First, in Kubernetes, you need to define requests and limits. Even if you know that is an impact, it helps to have Kubernetes working in a better way. So define QoS is crucial. If you have different namespace, define resource quotas, that makes sense. We get nothing to argue about it. And then, of course, observability. If you do testing, if you do production troubleshooting, you need to have a suitable observability solution in place, collecting metrics, logs, traces, creating alerting rules. That will help you to be more efficient. And last, as an SRE approach, we need to utilize, of course, load testing, K8s engineering, because we could obviously do a lot of things. And in fact, on top of that, like we described today, validate our Kubernetes settings through this SRE approach. And of course, if you're more mature, you can define SLI and SLO. So then you will be more efficient when you troubleshoot. Last, before we end this presentation, I would like to make a small promotion of my YouTube channel. So is it observable? So there is plenty of tutorials related to Litmus, to K8s engineering, to different type of Kubernetes aspects. So check it out. It's a young YouTube channel. So in order to produce better content, I need feedback. So check it out and send me your feedback so then I can improve and bring even more value to you guys. Here's my contact details. So if you have any questions related to what we discussed or discuss on other topics, you can reach me out on my email, Henrik Rexed @Dynatrace, or my Twitter handle, H Rexed. Thanks.